Welcome to Track E. This is the international track. I'm Carl Gerber, Chief Data Officer for Deloitte US. The MIT CDOIQ Symposium continues to expand our global reach. We have an excellent lineup of sessions that bring a world view. You are in session 13, Data Pipelines and How Their Construction is Important for Creating Robust and Scalable Applications for any organization. This session is being recorded. We'll have replays available for this and all sessions, together with the presentation materials for all attendees following the symposium. You have the ability to ask questions. We have a Q&A tab in Whova, so go ahead and put your questions in there and vote up those questions that you really want to hear. So with that, let me introduce you to our speaker, Mike Bachman. He prefers to go by Bachman. He's the Chief Architect, Office of the CTO at Boomi. He is, as his colleagues call him, the Chief Architect within the Office of the CTO at Boomi, a Dell Technologies business. He is responsible for Boomi's global position on emerging technologies and the pipelines that enable them. Bachman consults with the Dell Technologies Enterprise Architecture and Digital Transformation Groups responsible for Dell's largest global enterprises. Additionally, he works with his CTO staff colleagues, fellows, and distinguished engineers within Dell Technologies to create pan-Dell points of view on EM technology, on EM tech. Bachman, take it away.
Carl, thanks for having me. And I'm going to share my screen, if you don't mind, just so that we can get into a little bit of the discussion around pipelines. And so first of all, I'm just going to do a quick check with you. Do you see my screen?
Yes, we do.
Outstanding. Well, we do have a book that we wrote internally across different organs of Dell, Modern Enterprise Data Pipelines, which is digitally available now through Dell Technologies and eventually through my company, Boomi, as well. Boomi is at present a subsidiary of Dell, and we know our way around the data space pretty well, especially at the above the application layer. And so what we did is we created this book around modern enterprise data pipelines to serve a very important purpose, and maybe a little one that's a little more than just technology alone. It's really about organization. And one thing, Carl, and the rest of the viewers that we seem to find again and again, especially in the enterprise, is that data pipelines are important. The technical underpinnings of them are absolutely essential. Really, though, what a lot of problems stem from is the business and IT disconnects that happen. And so what we wanted to do was create a dialogue, a set of common principles and practices that both the business and IT could adhere to in order to understand what type of pipelines would achieve what types of outcomes. And ultimately, we're after an experience for a consumer at the edge of that pipeline that's going to be beneficial. So by the end of this session today, what I hope to impart in the next 20, 25 minutes or so before we get to Q&A is an understanding of what some of this nomenclature is and their importance, such as data pipelines, data fabric, endpoints, all of these terms that maybe the viewers and listeners know, but maybe there's some nuance in there that they could pick up. And if they don't know it, this is even better, because then we can help align the non-technical with the technical folks. Then we want to think about that alignment between those two areas, between business and IT as well. And we're going to talk about two essential layers of a design process that are at the experience, what we call the experience layer of the stack, as well as the outcome layer of the stack. Like I said, we'll talk about some definitions, take a look at some sample architecture. It's very high level. This isn't going to get deep into the tech. What it is going to do is sort of frame up future level discussions where we can get very deep into any technology we want to. And then we're going to envision a few different sort of patterned use cases around these pipelines, and then sort of establish a jump off point for any future discussions. So the first thing that we really want to impart is a transformative way of thinking. And really, when we were writing this book, this actually started out as an internal white paper. Inside of Dell Technologies, we have many different businesses, and oftentimes, our Dell Technologies standard is to focus on infrastructure hardware, and whether that hardware is supporting logical storage or compute frameworks, or not, something that's more physical or bare metal, if you will. Really, the Dell Technologies go-to-market has historically been focused around enabling the business through the infrastructure and the types of infrastructure that Dell Technologies can provide. From a Boomi standpoint, we're really concerned with application layer based communication and data movement. And so the idea of us having a message that's sort of in line with even our colleagues over on the infrastructure side of the business can sometimes get a little bit gray. And so what we wanted to do was create a way to talk about pipelines all the way through the architectural stack so that we could all be on the same page. And then also enable our colleagues over on the Dell Technologies, the infrastructure portion of the business, to be able to have meaningful conversations at the application and data layers. And so we wrote this white paper, which was eventually picked up, internally by engineering and technical marketing, and they implored us to turn it into a book. And so that's why we created a book about pipelines in general. And it's more than just, about Apache Airflow or any type of open source Kafka or any other types of pipelines that's set up for artificial intelligence. Those are certainly examples of the types of pipelines that we can address. But really what we wanted to do was align business and IT better and have better conversations between these two entities. Because for the past 20 years, since I've been, doing in a data engineering or data architecture role, these two entities typically end up asking for and delivering entirely different solutions. And sometimes they get it right, and sometimes they get the transformations right, but it's always a work in progress. And sometimes one simply doesn't understand the other, or one simply doesn't have the resources that the other needs. And so, they go elsewhere or try to source different tech in many different ways. And so by creating a common framework, we wanted to sort of ease the tension between the two. Now, we do address some concepts that are uniquely our own. They may be called something else in other areas of IT, but we came up with this concept of a state one and a state two architecture. And what we mean by a state one and a state two architecture in terms of transformation is the type of underlying infrastructure that exists to enable data movement between platforms, so we can essentially be abstracted from any underlying infrastructure, regardless of its location. It could be in a cloud, it could be on premises, it could be in a hybrid type of solution. But we really wanted to distinguish between the infrastructure architectural patterns that would enable us to talk about pipelines, applications, and data movement. And so in a state one, essentially what we're doing is we're talking about bare metal, we're talking about hypervisors, we're talking about ways that we can even containerize data independent or in lieu of hypervisors as well. But the idea is you have this sort of three-tier stack where you've got storage, you've got compute, you have some sort of abstraction layer that, or you may or may not have an abstraction layer between compute and the operating system so that your applications run on top of all of that infrastructure layer. But the idea is you have really a bound way in your own data center to be able to communicate with from application to application. And so what happens is if you have an on-premises sort of data center environment from a state one, it becomes very difficult to just move that to the cloud. And what happens oftentimes is that companies try to lift and shift what they have on premises into the cloud. So taking an old paradigm or a legacy paradigm and applying it to sort of a multi-cloud ecosystem doesn't necessarily work well. And so where a state two comes in is the ability to sort of abstract all of this underlying hardware so that you're just dealing with endpoints, pipelines, and you're essentially establishing what is going to be computed where. And oftentimes we hear of terms like, DevOps or infrastructure as code. Kubernetes is an example of a management ecosystem for different types of containers. How you're managing these different infrastructure components down at lower levels really enables cloud-based, cloud-to-cloud communication between different components of applications. And the better and smoother this process is by breaking down these various components into microservices or functions or something that's small and atomic, that really enables a lot of flexibility in different types of application architectures that are designed today. If you're simply trying to take a monolithic approach, which is perfectly reasonable in a lot of cases, and move it into a microservice without the ability to break down your monolith into those microservices very easily, it often ends in failure and transformation can't really get off the ground. So what we've been talking about here is we're assuming an abstracted layer in a state 2 for this particular discussion today. And the reason why we decided to go with this state 2 focus principally came from the fact that our sister company, VMware, was here to abstract away the underlying architecture so that we could really just build apps on top of either that type of platform or any type of platform like any cloud hyperscaler whatsoever. And whether we're talking about AWS, GCP, Tencent, Baidu, Azure, doesn't make a difference. To us, we want to focus our pipelines above the infrastructure layer. So this way we can allow any type of endpoint to talk to any other type of endpoint. And we go in depth in this in the book as well. So if you're looking for that book, I don't have a URL to give you today, unfortunately, but I will make sure to Carl to give you that after the meeting today. Now, we're going to take a shift out of infrastructure and really focus at the application and data layers right now. And what we have is something that before really 2015 was not attainable. What we have today is the ability to instantiate services of practically any kind in any type of cloud whatsoever. And so if you want to create an application out of these different services and look at these different services as endpoints, address them with API calls or remote procedural calls or whatever type of conduit you want between these different endpoints. The idea is you have best of breed services, geographically located services, different types of infrastructure services that are available to you to make your application run well. And so if you want to simply connect all of these dots, we wouldn't have been able to do so even a decade ago. Today, with the ability to containerize a lot of these services and to elastically scale them up or down, it makes it super easy to connect to an endpoint and abstract away all of the underlying infrastructure that's required to make sure that there's enough computational power, as well as enough persistent data storage that will coincide with what the application you're trying to build actually needs. And that allows folks like us in a space of, let's say, cloud-based middleware or modern-based application independent or infrastructure independent middleware like Boomi to be more like middle everywhere. So where we can be in the cloud, we can be on premises, we can be connecting applications and services anywhere we want to in a hybrid role as well. And so because we don't have to worry any longer about the underlying infrastructure that's associated with each one of these applications, or even if we did, as long as we're talking to the application endpoint, we can marry that application endpoint up to any other application we want to, because we're primarily focused at the data or application and data layers. Now, in order to transform, there are several things to keep in mind. Many businesses with legacy business processes or legacy applications have to transform to survive. An example of that is artificial intelligence. Artificial intelligence is, in my view, a new paradigm in computation, or it's not a new paradigm for sure, but it's let's say, a widely adopted or becoming widely adopted paradigm of computation, such that you can have complete scale with non-deterministic data. And what do I mean by that? I mean, artificial intelligence can operate at such scale right out of the gate, if implemented properly, that humans can't do in a deterministic way on the whole. Now, certainly, if there are only a few variables to worry about, only a few computations to perform, a single query, maybe that's not the case. But if we're trying to make sense of data, if we're trying to cluster, if we're trying to analyze, if we're trying to predict, if we're trying to prescribe, these are things that have been really very difficult for us to do in software development life cycles for a long time. But now, with the advent of easier and easier to implement endpoints that are driven by AI, whether it's machine learning, deep learning, reinforcement learning, anything like that, if a business doesn't use these types of computational resources as part of its overall application, the chances of that application really thriving are slim, and really it diminishes that business's ability to survive in the long run. Additionally, transforming to thrive is important too. More and more businesses, regardless of size, regardless of scope, are implementing all sorts of different types of data source technology, such as edge-based IoT data sources. The more data sources we have, the more the need is going to be for high-end multivariate computational resources like artificial intelligence. And with that, that is going to enable businesses to thrive. Additionally, different types of pipelines that are set up to determine version control and consistency, like CI/CD pipelines as an example, whether we're talking about Jenkins, Ansible, anything of that ilk, using different pipelines to make sure that code is, as it changes, has the ability to transform the actual application is essential. So transforming continuously is certainly important. And the last two we're going to talk about in a little more depth, but our approach in the Office of the CTO and certain in Boomi, and certainly it's been my experience to focus at two levels that as technologists we often forget about, and that's where the business is really focused. And that's one, at the subjective layer of the human experience or the experience of the end user, and two is the objective outcome that the business is going to measure that subjective experience. More on that in just a little bit, but those transformations are essential as well. So let's have a couple of terms and concepts. We have about another 15 minutes to go here, and then we can start engaging in some Q&A. So what is an application? This is a sore subject of debate for many of my colleagues and me, but I challenge that there is no standard definition of what an application is. In fact, some of my colleagues try to distinguish between an application and a service, but I'm going to narrowly define what I mean by application in just a second. And that is, there's some input, there's some processing, and there's some output, and that's it. And if we consider that as an application just for a moment, and certainly, feel free to disagree. I would welcome that, in fact. But for right now, we're going to operate under this lens, and we're going to say that with input, with processing, with output, then we essentially have an application. And that is a superset of something like a service, something like a daemon, something like any type of call that could be made in some way. If you have a source of input and you're doing something to that source of input in order to make it into output, even if you're just passing it and doing nothing to it, the act of passing alone, to me, suggests an application, and it could be that simple. So that said, in the book, we talk about an input pipeline and an output pipeline, and there's essentially 5 components. You take raw sourced data from somewhere, you stage it in a meaningful way, and then you do something to it. Once you've done that thing to it, which we'll get into in just a second, that becomes consumable to another application or to another service. And so at that particular point, once that particular service has it, there's got to be a why. And that is where the outcome execution comes in, to where we can get to something that's higher order, like a subjective layer. What are data pipelines? Data pipelines are processes that involve sourcing data from one place, processing that data through some ordered sequence of actions, and targeting the end data, the refined data, to some location that's desirable. And as an example, with AI, I bring this up because, this is just a Canadian AI ecosystem from a couple of years ago. But look at how many companies are on there today. Now, I wonder how many of those actually exist at this point. And coming out of MIT, I wonder how many applications you've all built inside of MIT or any other companies that work with MIT. But the idea of AI applications alone, there's just this this explosion of different types of applications that are there to process data at scale. Some more specific, others more general, but still they're processing data at scale in ways we can't. And so one thing I like to tell a lot of folks I talk to is big data, small apps, massive headaches. So what does that mean? This whole version of big data, where we've got centralized repositories of data in some meaningful way that are being computed on top of by these teeny tiny small apps, creating endpoints with their own metadata, and they all need to talk to each other in some sort of sequence, can be really problematic. And so when we talk about pipelines, it's important to understand where along the pipe we're going to inject different points of computation. Are we going to have the computation closer to the data? Are we going to persist data? Are we going to pass data and not persist it? Are we going to cache it? What are we going to do in these pipelines in order to achieve our desired outcomes? So again, get data, process data, orchestrate outcome through your input and output pipelines. Now, experience and outcome first. So we're going to flip on its head the technical conversation and really talk about the subjective layer and get down into the objective layer. And that is, we're going to start with how the pipeline will benefit the consumer, the end consumer, and what that desired outcome is. Then we need to understand the data sources necessary to achieve or derive what those objectives are, who owns them, and what it takes to access them. And then finally, examine and define the optimal process by which we're going to move this data from start to finish. And so what we've done is we've created a pragmatic data strategy. Now, pragmatic data strategy is a framework that we use to help us walk some of our customers or some of our prospects, some of our clients, through a structural way to deal with their application pipelines. So again, we're going to start with the experience, the subjective layer first, and then we're going to go into the outcome layer and what we need to orchestrate to create some sort of quantitative way to evaluate or to objectively define what the outcome is. So experience is subjective, but the outcome is objective. Is there a way to measure the subjective with the objective? And the short answer is, yeah, there is. Oops, I skipped ahead a little too fast. So for instance, if you wanted to create some sort of immersive AR Pokemon Go like experience for your customer and make them feel, or your consumer, and make them feel like they were a part of the landscape catching different Pokemon. My kids are really into Pokemon. So they want to feel like they're catching Pikachu or Eevee or one of those, right? In order to do that, you have to make that thing seem like it's real. Otherwise, it's going to lose a lot of its luster and it's not going to be used. Well, you can assume objectively that if the more interfaces that you have that keep your users coming back is going to create a higher click rate. So maybe an objective way to measure whether or not your application is successful or the AR is good is the amount of feedback that you're getting, the amount of tickets that you have, the amount of overall clicks that you have on different cartoons that you put out in front of your users as an example. And that immersive experience can then be measured in terms of click rate and that sort of thing. You can further use AI to help you define variables that you wouldn't otherwise expect. And I don't have any to give you at the moment, but not in this particular context that I'm just throwing out there. But I can tell you from a business standpoint, one thing that we're evaluating inside of Boomi is how we can create what are some objective ways to measure how sales are going to be next quarter and try to predict that. Are we using the right variables or not? Well, we work with some AI partners where we can simply plug into our data sources inside of our own company, present them to our AI vendors, and then they can tell us some enlightening things about our own data that we would have never guessed if we would have deterministically come up with those metrics as, just as our puny little human brains would allow us to do. Data fabrics. Let's talk about this architectural concept for a moment. To us, what a data fabric truly is a comprehensive set of endpoints, services, processes, and abstracted pipelines even, API calls, services, anything like that, that can be used in combination or permutation to achieve digital outcomes. And so as an example, pipelines or data fabrics in general consist of all of these components and more. I do not account for everything in this pragmatic data strategy. That's why it's called a pragmatic data strategy, not the pragmatic data strategy. It's meant to be kind of a conceptual map for folks to think about all of the different tools that they might have in their data fabric. And pipelines are part of that data fabric. I think of pipelines as a thread in the fabric, if you will. And that could mean something like, if I want a timely experience, and that timely experience is measured by the amount of self-service components in an application that get clicked on, well, I might have a pipeline that first is going to tell me in my self-service catalog, I have to know where all my data sources are. I have to catalog that metadata. I have to prepare it for a given pipeline. Maybe I'm going to use some sort of event-driven architecture like Kafka or Pravega or Solace or Pulsar, something like that, an event-driven real-time streaming type of architecture that's going to not only save all my logs, but it's also going to be a persistent store for my data. And that can be available into some sort of computational service or out of a computational service as well. And those services can simply be connections to data sources. They can integrate multiple data sources and bring tables from this data source with objects of this data source, merge them together and transform them in a way that's going to be consumed by something like Spark or Flink in that particular library. And then once that's processed, then it will be sort of output to another channel where we can abstract that layer with an API call of some kind, and then wrap some controls around that in the process to determine the number of folks who can access a service, or the number of times folks can access a service throughout the course of the day, or have some sort of attribute or role-based access control or attribute-based access control along the way. And so by doing this, we're creating pipelines out of our data fabric. We throw around this word a lot, endpoint, and all an endpoint is to us is a connected node within a pipeline that serves as a source for raw data or a target for process data. And these nodes are really abstractions of the underlying physical or logical interfaces and their functions. So what we can do is essentially create an endpoint out of an entire business process consisting of a bunch of endpoints. And so that layer of abstraction really allows all sorts of things to be able to happen. So just think of booting up your computer as an example. That all happens in sequence. But imagine if you were using Kubernetes to orchestrate the boot up of a server, you're bootstrapping a server of some kind. There are a whole bunch of things going on under there. You're making one call with your operator to make that service come to life and perform whatever function it's going to perform. So from a Boomi standpoint, and we're getting close to wrapping up here, we are, let me go back here. Boomi is a low-code application development framework with intelligent data services. And we have a cloud-based design time and a place anywhere runtime. And so the idea is we can scale up or scale down, however is necessary, in a variety of ways. We can connect SaaS applications to cloud native applications, to on-premises applications, and we could do so all in one common interface. And so when we talk of data pipelines, we really don't worry about the underlying infrastructure, because we're going to talk from one application interface to another application interface and transform and move the data based on whatever the process is going to be in order to achieve a desired outcome, such that we can lead to an overall experience, a desired experience for the end consumer. And oftentimes in our processing pipeline, we can do batch, we can do real time. We have all of these tools and partners available to us in our ecosystem. But essentially what we're trying to do is make data pipelines easy for our customers to build. And in those pipelines themselves, these are just an example, excuse me, of the different types of processing that can go on with the data pipeline. Now I'm just going to do a quick time check because I think I'm running up on the end here. All right. We're not going to get into everything from here, but whether we're talking about structured, semi-structured, even unstructured data, this is part of the pipeline. Data warehouses, data marts, data lakes, these all have different purposes and all serve different functions for different types of businesses. For us, we want to merge all of these together. And we're not going to get into the common patterns today because clearly we're running out of time, but I do want to say that common patterns for app-to-app communication really resides both at the API layer as well as PubSub today for modern multi-cloud fabrics. Okay, we have some examples. You could take a look at those in the slides. We talk about some common customer service examples, artificial intelligence examples, even edge and IoT examples, and bringing it all together. But essentially, Boomi is at the heart of a lot of the inter-app communication, from fabric to fabric, using a variety of different conduit. And so we've covered a lot of ground today. Modern enterprise data pipelines is a very high-level overview of all of this. It's about 100 pages, but it's a good read if you want to align business and IT. And we encourage you to download it. And again, Carl, I'll provide that link to you going forward. So that's all I have for today. I hope I didn't overstep there. I know we've only got a few minutes left. Apologies.
All right. Well, thank you, Bachman. We have time for one question. As far as your link to your book goes, send us an updated copy of your presentation with the link, and then it'll just be published with all of the materials.
Sounds great.
So I know you kind of moved fast through the end there with some examples of pipelines, but that's the question. What are some widely used, well-accepted pipelines in use today? So maybe you could just pick one and talk about, like the pattern there, maybe your IoT or your edge case, but why don't you explain one of them, because that was the nature of the question.
Okay, great. So, today wasn't meant to be getting into pipeline specifics, but let's give you an example of a customer 360, student 360, something like this. Oftentimes what happens is there are a variety of different data sources, like from an ERP system, from a CRM system, from a supply chain management system. When you're ordering something, when you're trying to anticipate if something's going to break, all of these different components have different signals as endpoints, and those all need to be merged in a meaningful way in sequence in order to achieve a desired outcome. And so an example of a pipeline would be connecting to these various endpoints from an ERP system to a phone system to, what have you. And if we wanted, for instance, a chatbot to intermediate between, a user so that we could help that user replace a part that's about to break down after we've signaled to that user that we're sending her a replacement part for her manufacturer or her manufacturing floor system, then great. That involves a variety of different workflows, and it involves a variety of different endpoints, each doing a variety of different things. So in this particular case, we go into this in the book pretty heavily, but the idea is, if you're looking at the human component versus sort of an automated component, there are different workflows that are associated with each one of those that need to be married in order to create tickets. And then in order to make sure that the customer is satisfied with the end result, in this case, which is getting the part shipped to her. So we're going to use a variety of web API calls to make this happen between those different endpoints. We're going to be using a pub sub service of some kind, whether that's Kafka or Pravega or Solace, something like that. We're going to have a number of different producers and subscribers to different topics or different streams within this process, but we need a way to get the data into this queue, and we need to get and then from there, it needs to be processed, maybe by an AI engine, or maybe by something that's more deterministic in nature, standard logic, queries from SQL, for instance, or SQL. And then once the data has been properly munged, queried, processed, then it can be output to a topic, which can then be consumed by downstream applications. And from that point, Boomi can then, again, orchestrate meaningful output, saying to the end user, here's an email, here's a message, here is when your shipment's going to arrive, here's your chatbot giving you all of that information, those sorts of things. And that's really detailed in the book.
Excellent. So a follow-up question, you have 2 minutes, so this is like lightning round here. When you're constructing this pipeline, you have multiple and very varied endpoints, and each endpoint is represented in a different semantic model. How do you deal with those differences as you construct your pipeline?
Very carefully. No, don't mean to be cheeky there. No, it really depends again on the experience, the overall subjective experience, and the objectives that are going to be measured along the way. That's tended to work well for us. So modeling sort of, if it's a current pipeline that needs to be optimized, typically what happens is we'll take a look at the workflow as it is today, look at the desired outcome, and then see what it's going to take to get to the desired outcome from where we're at. If we're in a completely, brand new scenario, that's a different story. Then we don't have to take things like tech debt into consideration. At that point, we can define whatever semantic model we want of the data. We can take a look at the different types of endpoints that we would want to stitch together in the pipeline. And we can make that as comprehensive or as simple as we choose. But again, the guiding principle is, what are we trying to get to with the overall integrated experience, the subjective side of things? And then how are we going to appropriately measure that? How does the business want to measure that? Or how does our end customer, whether that's the business or another group in IT, or an end customer like my kids and their Pokemon Go experience, how are we going to measure that properly? And that is going to define for us how we need to do things. We haven't even touched governance, Carl, but there are a lot of factors there too.
All right. Well, I can assure you we can't touch governance in the remaining time. So Bachman, thank you very much for giving us this overview of data pipelines.
Thank you for your time. We really appreciate it.
All right. And this concludes our session.